Okay guys, so in today's lesson we are going to be talking about trapezoidal approximations.
Trapezoids, 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 trap.
What's up guys? So today we are going to be learning about trapezoidal approximations, which is basically approximating the area under the curve of any given function using trapezoids instead of the traditional rectangles that we use in left Riemann and right Riemann sun. So how we do this is, so for this curve right here, normally we would do for a right Riemann sun, it would be like this, making the triangle like this, making it a big over approximation. But with this, you make a point right here, let's say this is 1 and 2. With the x-axis, you make this, and then you connect these and bring it down like this. This isn't very sloped, so I'll try it again on a larger slope like this. So you connect these two like this, and then so your area under the curve would be the area of this whole triangle right here. And it's just a more precise way to measure the area under the curve as opposed to the regular rectangle.
Okay guys, so in earlier videos we've talked about LRAM, RAM, and MRAM. And with LRAM you get some under approximation like so. And with RAM you get over approximation like so. Now with trapezoidal approximation, while there still is some error in your approximation, it's a lot less, and you're going to get a lot more precise of an approximation.
So at this point in the video, you may be wondering how to actually solve for the area under the curve using these trapezoids, and it's a very simple formula. It's area equals 1/2 the height times the summation of the two bases. And so what does that mean? I'm going to just explain it. So if you come over here to this graph we got here, let's say this is the equation that you're given. Maybe it's x squared plus 2 or whatever, and you need to find the area under the curve. The way you'd use trapezoids doing this is, so let's say it tells you to do 2 trapezoids, and this is at 10. You would start right here at the beginning. You'd make 2 points, one at the 0 and one at the 5, and you connect them, and then you draw a trapezoid like this using these connected points right here, and then you do it again over here at 10. Sorry, it's a bad drawing. And so then you have these 2 trapezoids like this. And so how you do it for this first one is, when it says base, the base is, if you think about it like a regular trapezoid, if you look at it like this, so it's kind of like this now. This is base 1 and this is base 2, and this is the height. So if we come back like this is the height, and this is the 2 bases. So the formula that's given is the area for just one trapezoid. So for the problem like this that we had a second ago, you would have to do 2 areas, so 1/2 of 5, 5 being the height, that was from right here, times base 1, which is 5, plus base 2, which is 6, making that 11. And then, since there's 2 trapezoids in this, you'd have to add a second trapezoid, add 1/2, 5 again for this height, times base 1, which is 6 again, these 2 overlap, plus 10, which is over here, that was just 10, 10, making that 16. So we come to this, we got 55 over 2 plus 80 over 2, which gives us 135 over 2, which we can simplify to equal 67.5, and that is going to be your area under the curve.
So at this point in the video, you guys are probably wondering, why on God's green earth do I need to know this? Well, I'll explain it to you. So some definite integrals such as e to the negative x squared dx can't be solved by just integrating like we usually do. And that's because we don't know any basic functions that are antiderivatives of e to the negative x squared. So by using trapezoidal approximation, we can approximate the area underneath this curve, which is e to the negative x squared, and that's why it's applicable to what we're learning right now.
Trapezoids!
Okay, so here's an example to clear some things up for you guys. So in this example, we're using the equation y equals x squared plus 2 with a subinterval of 3, meaning we're going to be using 3 trapezoids. So here I have the integral written out, and I have the equation, h over 2 plus all the bases that we're going to be using. Now, with each of the heights of the trapezoids being 1 over 2, we have 0.5 times 2, which is the first base, plus 2 times 3. And the reason I have 2 written out front is because these two trapezoids share the same base of 3. And same with these two trapezoids sharing the same base of 5. So I simplified the equation a little bit here. So this is all going to come out to 0.5 times 29. And when you multiply those together, you get 29 over 2, which is going to be your approximate area of this equation.